Hello, and welcome to today's webinar, On-Ramp to Microservices, Learn Valuable Insight from 8x8's Journey. My name is Jeremy Schwartz, and I will be your host for today's presentation. Our featured speakers today are Pankaj Gupta, Senior Director, Product Marketing, Citrix, Lance Johnson, Director, Engineering and Cloud R&D at 8x8, and Michael Laws, Senior Site Reliability Engineer at 8x8. Before we get started, let me cover a couple of housekeeping details. We will have a dedicated question and answer session at the end of today's presentation, and I invite you to submit your questions at any time during the presentation using the Ask a Question window in the webinar interface. Also, this event is being recorded, and a link to the on-demand version will be sent to everyone in a follow-up email. With that, I'll hand it over to Pankaj to start the presentation. Welcome, and thank you for joining us.
Thank you, Jeremy, and welcome to the Citrix webinar. I'll be covering briefly about the drivers to microservices-based applications, Citrix's key principles for building and delivering the microservices-based application delivery platform, and why Citrix, and then we will have our star presenters from 8x8, Lance and Mike. There are three key drivers which are driving our customers, enterprises, to move to the microservices-based applications. Number one, inherently modular application architecture. You take a large monolithic application and you slice into small services. And the benefit of having multiple microservices that each can be developed, deployed, and auto-scale independently. So that gives you a lot of agility. Second big driver for microservices-based application, which is any DevOps or CI/CD team's dream, is the faster releases. You will like to roll out frequent application updates, not just monthly, not just daily, but many times in a day. And you can also automate deployment with continuous delivery. And in the world of multi-cloud, portability is very, very big driver. Each microservice is a self-contained runtime. So you can move your applications from on-prem to cloud, or from one cloud provider to another cloud provider. If you want to learn more about the reasons why you should consider microservices-based application, I strongly recommend to click on that URL, tinyurl/k8apps, and there is a detailed discussion which walks you about what are the key drivers for microservices-based applications. Addressing DevOps and application developers and NetOps team, Citrix has built a microservices application delivery platform on 5 principles. And these 5 principles are aligned with your journey as you deploy microservices-based applications or even evaluate various microservices application delivery platform. First principle, giving you the architecture of flexibility. Each DevOps, each platform team, each IT organization is different. And they will like to balance the benefits and the flexibility for choosing the right architecture. Citrix offers 4 architectures, starting from simplest and easiest and fastest to deploy, which is 2-tier ingress, to the North Star architecture is the service mesh, which Lance is going to talk a little bit more. So we also support service mesh. And if you want service mesh features but less complexity, Citrix also is service mesh light functionality, which you can learn more about the white paper, which is linked in the subtitle of the slide. Second big principle of Citrix solution is our solution will integrate with your choice of Kubernetes platform and also the open source tool chain which you are using or plan to deploy. Citrix support all major cloud platforms for Kubernetes like AKS, Azure, or GCP, including Red Hat OpenShift. For tools, we support a very broad variety of open source tools from Prometheus, Grafana, and many, many more, including Spinnaker for CI/CD. Third principle of our solution is ability to give you better performance, higher scale, and lower latency. Multiple tests have shown at Citrix that Citrix ADCs, which are also called proxies, gives you a higher performance than its peers and gives you the lower latency. And latency is very, very critical because typical request goes through multiple microservices, and each microservices can add additional latency to it. So having a proxy which has the lowest latency is very, very critical. And Citrix 20 years of experience of building the ADCs is translated into a faster and lower latency proxies. Fourth principle is consistent application and API security. Citrix has been building WAF and appending WAF with bot management and API gateway functionality. Now we are extending same to microservices-based applications. So you can have a consistent security posture across your monoliths and microservices-based application. Many times, what we hear from our customers, the visibility inside the Kubernetes cluster remains a mystery. For that, Citrix has built a complete observability stack, which includes logs, matrices, tracing, and innovative service graphs, which shows you multiple dependencies between the microservices and also gives you insight about health of each and every microservice. So instead of taking a fragmented approach for observability, Citrix is taking a very stack view of the observability for that. And most important, when you combine these 5 principles, we want to offer a production-grade solution so you can deploy your new microservices-based applications at the speed which makes sense for you. To summarize, there are 3 key benefits which Citrix brings for your journey to microservices-based application. First is go faster. And go faster comes because of the 3 key reasons. We offer a production-grade solution. Second one, it is already pre-integrated with your choice of Kubernetes platform and open source tools. So you don't have to build the science project yourself. We give you a pre-integrated solution. And third is the way we offer our solutions through a pool licensing capacity. So you can move your licenses from one cloud to another cloud, from one deployment to another cloud, because many of you are in the journey for moving from monoliths to microservices or moving from one cloud environment to another cloud environment. Second big benefit which we bring is reducing the risk as you take your journey to microservices. Citrix offers committed support for our solution, so you need not to depend on community, you get a committed support from Citrix. We give you the choice of architecture, so you can balance between simplicity and benefits, and also we reduce the risk by giving you a holistic observability stack. And security has to be a first principle for everything which you develop, and that's where Citrix brings a consistent security posture for monoliths and microservices, so you do not have gap into the security. We also bring a very comprehensive API and application protection, which includes WAF, bot management, API gateway, and you can not only just protect your north-south, but also protect east-west traffic if they are deployed in service mesh environment or service mesh light. So you can transition to your microservices-based applications with more confidence. With that, Lance?
All right, thank you, Prakash, and thank you, Jeremy. Thanks to Citrix for hosting. So Hi, I'm here with a colleague of mine. We work at a company called 8x8, and we're here to talk about an analogy I like to call the DevOps three-body problem. So my name's Lance Johnson. I'm here with Mike Laws. 8x8 is a unified communications platform, and we work hard to try and keep the teams moving along, whether it's on-prem or in the cloud, and keep things going, and stuff like that. So here you can reach me on these social media links. I have a CS degree background and spent half my career in operations and half my career in engineering. But some of my most favorite and cherished badges are on my laptop. If you see this laptop at a conference, please stop by and say hi to me. My wife jokes all the time that anytime I say I'm going to a conference, she's like, "Yeah, you're going to a sticker trading fair." And the irony is this laptop, because of this collection of stickers, has kept me on the exact same processor and memory setup for like 6 years now. I'm kind of trapped, but
yeah. What's amazing is that it looks like a Mac under all those stickers, but it's actually an old compact 386.
Nice. Yeah, so 8x8 is a unified communications platform. It's a one-stop shopping. We're actually a fairly big company. It feels like a startup, but it's big. We've got close to 2,000 employees in many different countries. We've got endpoints all over the world in every country you can think of, and we provide a unified experience for communications, regardless of whether or not you're doing meetings or just doing voice or chat or even talking to your customers directly. So it's a one-stop shop. So what is the three-body problem? Essentially, it's an unsolvable mathematical problem, and I think when even Newton, he was able to invent calculus just to describe his thoughts when he was figuring out how the heavenly bodies moved. This problem still almost drove him insane, because there's no closed form solution that predicts the path of the once you have that third body in there. So what does that mean with respect to DevOps? So what are the three bodies? Well, first you've got to get your service and your stuff put in place, right? So you've got the rudimentary, you've got the exotic, you've got Ansible, Chef, Terraform, CloudFormation. It's a myriad of all different kinds of things, and so you got to get your stuff in place. The next leg of that stool is how do you get your customers to the right service? How do you route them or get them connecting to the right place, right? So there's a myriad of different ways of doing DNS, including geo. There's many different proxies and whatnot. And then finally, we're all kind of on the same journey, and 8x8 is a 25-year-old company, and we're all working on refreshing and moving monoliths to refresh technology and microservices and stuff. But you still have persistence and legacy systems, files and databases, and different data centers, and random VPCs all over the place, and public and private. So each one of these pulls with varying gravity based on who's screaming the loudest. So that's why I consider it pretty difficult challenge for DevOps. So how did we approach the problem? With a little bit of style, but we've gone through a lot and we've experienced a lot, and I think we've had some good successes. But even though sometimes I felt like we're pretending to ride a horse as opposed to actually riding a horse. I throw this slide into every single presentation, and it regardless of the context, and it drives my boss crazy sometimes. But I really want to drive it home. It's kind of the foundation of the mindset and the philosophy that we want everyone at 8x8 approaching all of our problems. So we want to be able to approach things safely, be able to make sure that whatever happened or whatever got deployed can be tested and validated. Everything has to be automated, and you want to be able to do the exact same thing in every single environment. We want to do it in an open, collaborative fashion so that everyone learns about it, and we want to provide autonomy for teams. You get you get those teams up and running, and if they never have to come back to you, they actually they'll love you for it, So that's it's the basic DevOps story essentially. I think everyone kind of views it that way. So, which microservices and how did we approach it? Well, so the why is easy. It's just like Pankaj alluded to earlier. You want to divide and conquer as you slowly, do your refreshes. I don't think I know anyone or have been in any situation where someone had a stalwart application that's old but needed to be renewed, and they started from scratch and just rewrote the whole thing. It's a slow migration sometimes. But that's where microservices can really shine, because you can peel off a piece at a time and do it seamlessly.
Let's now 8x8 have hundreds of microservices. When you started the journey, how did you pick that which microservices should be developed first?
Sure. So this is an actual screenshot from one of our consoles that shows it. So every one of those octagons is an actual service, and it represents at least one or more teams that's developing a service. And so, we at 8x8 historically, voice quality is number one. We don't ever want to impact that quality. So, it had kind of a trickle down effect on some of the technologies we chose. And so, containerization we chose just more recently in the last few years. And so we were able to, since that was a brand new packaging and a brand new deployment mechanism, one of the first set of services we did was kind of a foundational framework of services that support other services. So how do we provide configuration? How do we do RBAC and all those kinds of things? How do we handle authentication and stuff like that? So those are the first services that went. The other thing we did was, since Kubernetes was the paradigm we chose, we said, well, it's going to be complex to learn. Let's just start with stateless applications. So, I talk about it a lot in the next few slides and stuff, but those are the first ones that went, essentially.
Thank you.
Mm-hmm. And so what were our design goals? It's the traditional Kubernetes story. We wanted a uniform deployment regardless of which environment. So all the clusters, once you kind of lift those developers up into the state definition that is Kubernetes, then they don't care where it's deployed as long as it's performant and kind of does what they expect. So that truly is the secret sauce, or what makes Kubernetes so popular at this point. We wanted service discovery, we wanted high availability, automatic recovery, and we wanted to stay really native to Kubernetes. We didn't want too many exotic stuff. We wanted to be able to use as many public charts as is off the Helm charts. But we did, as part of the framework that I talked about, we created it comes with a scaffolding, and part of that scaffolding is it generates a chart. So most teams at 8x8, their charts are super simple. They just include one common chart, and then they call a template that's provided in that common chart, and that's it. So it's like one line, and then we take care of everything else. So it's worked out really well. So this is kind of the same view, but just without the 3D, just to kind of talk about it. So we took Kubernetes, we spread it across multiple availability zones. We went stateless with most of the first initial services, so we didn't have to worry about kind of EBS is trapped within an AZ. The east-west we worked on, we used a database with a simple kind of replication. It's based on the CAP theorem. It's not for like a super high IO or really demanding OLTP, but it's good enough for what we needed. You can only go so far with the CAP theorem, and then we put a cloud deployed load balancer in front of it, mainly because we had some demands for bring your own IP, and we knew eventually we would be introducing on-prem stuff as well. So that's how we kind of coalesced. And Cloudflare at the time was the most feature-rich, so that's where we went. So our hybrid environment. So now how did we progress and where are we going now? So So as we first learned, we spun up Kubernetes. We went cloud first, and I'll talk about that more later. But we quickly learned, well, you can't just have one cluster for the whole world, right? So we started needing more and more clusters in any particular environment or promotional phase is many different clusters eventually. And we stuck a cloud load balancer in front of it, and that allowed us to kind of insulate the cluster from the users. But we quickly continued to expand. We wanted the US to be east and west, and with that insulation from the clusters, we could bring on we could either do in-place upgrades, or we could just put a whole new cluster right next to it, and then slowly bring the traffic over. Plus, we could start entertaining some of the managed service Kubernetes, namely EKS. We started in 1.8, probably about a year before EKS was released. And then the pattern continues on and works well even with the on-prem stuff. And, so Citrix has been great because it allows us to stay very native to Kubernetes, and it works really well with the Kubernetes providers as is. Like the development teams are impacted almost zero. Like operations, we might need to use different annotations and stuff, but it works exactly the same. So we've been pretty happy with that. And then now there's a plethora of Kubernetes managed services, and OKE is another one we're spinning up right now.
Citrix ADCs, or application delivery controllers, were previously branded as Citrix Natiscaler. So Citrix Natiscaler is now being branded and called as Citrix ADCs.
Yep. Yeah. So that's how our hybrid environment looks for a particular region. And then the on-prem stuff, I'll let Mike speak to this infrastructure.
All right. Thank you, Lance. I'll spend just a couple of minutes digging into kind of that continuation of the architecture Lance was talking about, where we started in the cloud. We brought our microservices into Kubernetes, these stateful microservices. And then as we started to expand those microservices beyond kind of those more simple stateless microservices, that started to bring up the there's additional dependencies with some of the stuff we have on-prem. So back to what Lance was saying, we've 8x8's a 25-year-old company. And so we were kind of born in the data center and then moved into cloud. And so we still have a lot of legacy, I'll call it, in our data centers, data stores, databases, just a ton of persistence, I'll call it, in the data center. And so what we needed to do was we needed to bring a Kubernetes presence into our data center, and that fits perfectly into the architecture Lance was talking about. And so what we ended up doing, just briefly, is it kind of involved a much larger redesign of our data center practice. So what we ended up doing was taking kind of a top to bottom second look at what we're doing in the data center, and ultimately landed on this zone-based approach. So mimicking the concept of availability zones. So these are basically fault domain boundaries at the end of the day, and that allows us to easily articulate the placement of resources within the infrastructure to minimize single points of failure upstream from our application. So that's a kind of a mouthful, but that allows us to say, okay, rather than getting into the nitty gritty of exactly which servers we're placing workloads on, we have now this kind of this abstract concept of an availability zone that represents those fault domains. Anyways, that plays really well with the Kubernetes architecture as well, and also mirrors kind of what we've become used to in the cloud as well, with the notion of availability zones or availability domains or what have you, depending on your cloud provider. So what we ended up doing was deploying a 3-zone architecture in our network on-prem, and then deploying Kubernetes within that. And just some highlights, we're currently running 117.6 on-prem. It's a layer 3 leaf spine architecture, And it's laid out essentially like what you see here in this slide here. We have our control plane distributed across the 3 zones. So we have etcd and the Kubernetes API distributed across those 3 zones, as well as the Kubernetes worker nodes, of course, and with the appropriate annotations that allows your application teams to then make deployment decisions based on those topology hints that we provide to Kubernetes. So we can say, hey, deploy 3 instances of an application, and Kubernetes will take care of making sure that instance 1 is in zone 1, instance 2 is in zone 2, instance 3 is in zone 3, and so on. Storage is also an important part of that. So we also took a second look at how we're handling storage, which I think a lot of shops out there were probably in the same boat, where there's a lot of monolithic storage. You put a lot of kind of security and operational kind of guardrails around that and hope that it doesn't fall over. And of course it always does. But but what we did was we basically took the approach of let's dedicate storage to each one of these zones and ensure that there's zero dependency from the infrastructure side across those storage platforms in each zone. And of course, that plays perfectly with Kubernetes as well, the persistent volume concept. So we can easily deploy, for example, a database into Kubernetes, request a persistent volume. Our storage layer will provision that volume, mount it to the appropriate Kubernetes worker node, and off you go. So it's the ultimate goal of all of this was really to, going back to what Lance was saying about some of those important things like sticking to the Kubernetes native kind of APIs and constructs. What we wanted to do is provide a Kubernetes infrastructure on-prem with little to no changes from what we're doing in the cloud. And I feel like we accomplished that, and we'll talk a little bit about that here in a moment. But another important piece of that is, I won't go into too much detail, but the tight integration with our networking infrastructure. So that's BGP, route reflectors, Calico. It's a whole probably other conversation that I won't get into here. But another important piece is the how do you get traffic into the cluster, and that's the Citrix ADCs, formerly NetScaler. And so the Citrix ADCs were an important part of making this on-prem Kubernetes cluster work. You wouldn't be able to get traffic into the cluster very easily without that. And so that provides kind of our what Citrix calls a unified ingress into the Kubernetes cluster. So we have that Citrix ADC infrastructure also distributed across these 3 zones with no interdependencies between them. So at the end of the day, if we lose a zone due to a hardware issue, a fault somewhere upstream, whatever it is, a firmware upgrade gone wrong, whatever it is, we can survive a failure in a particular zone with no infrastructure dependencies that would impact the surviving zones. So that's Citrix was a huge help in making all of that happen. So let me move to the next slide here, and I want to just dig in really briefly to kind of the detailed anatomy of a zone. And I talked to a lot of this already, but each zone is exactly the same. We have high-speed links up to our leaf spine infrastructure upstream. So we resolved a lot of kind of the potential I/O contention, network bandwidth, all of that sort of stuff. We've completely upgraded a lot of what we're doing just in the core networking. But a big piece of that was to provide the interfaces we need to have Citrix, Kubernetes, and other applications that are outside of Kubernetes be able to advertise IPs and VIPs directly into the network. And that was kind of a key design decision to aid in kind of massive scalability. You can get to a certain point with VLANs and subnets and all of that sort of stuff, but we really wanted to move into a sort of a pure layer 3 topology, which is what we have with our Kubernetes infrastructure.
Did you use the service type load balancer? And if yes, why?
The load balancer, so I can speak to part of that. I know that and this goes back to, Kubernetes experience in other companies as well, that the service type load balancer was the way to get traffic into your cluster. And the notion of an ingress was kind of a new foreign concept that came later, and I think it was more of an optimization. And I can let Lance kind of speak to more of those details as well. I think he has a little more insight into that decision.
Yeah, it was a little easier concept for teams to understand, because the service object in Kubernetes maps very exactly to what a traditional load balancer is, so people understood it much easier than a full ingress is a little closer to a full like service mesh and like mapping. I mean, it's a little more of a proxy, and it was just more confusing for people as they were trying to learn Kubernetes.
Thank you. And I believe you use Citrix VPX as a Citrix ADC.
That's correct. So one of the the Citrix team, by the way, was incredible in kind of helping us land on the right architecture. We came into our we came into this with a lot of ideas for how we wanted to see this scale. And Citrix, it's kind of a testament to the flexibility of the platform. We were able to plug this in, and within just I would literally say a couple of days of just some initial setup, deployment, working through some kinks, we had a fully functioning, scalable ADC tier in front of our Kubernetes infrastructure, which is incredible. It's integration with BGP. So when we deploy a new service into Kubernetes, it's assigned a VIP using Citrix IPAM, and that VIP, the minute we see those services come online and health checks start passing in Kubernetes, that VIP, it gets advertised by the ADCs, and our network basically handles the rest in terms of getting traffic. But what's really cool about that design is that, an ADC VPX is the virtual appliance, and due to more, I would say, limitations on your virtualization side of things, whether it's VMware or whatever the technology is you're using, you're going to have a certain limit to how much, for example, SSL throughput you're going to get out of a particular appliance. And I won't go into all the details, but with this architecture, it allows us to horizontally scale that tier using the Citrix ADC. So as our throughput demands increase, it's really trivial for us to add another ADC to each zone or several ADCs to each zone. So it's a very flexible architecture for us. And I mentioned BGP to the network, and I can't stress that enough. Calico is our networking plugin, our CNI that we're using for pod-to-pod communications, as well as some more kind of exotic direct-to-pod use cases that we're looking into that I won't go too much into here, but it's been a super flexible architecture so far, and like I said, it's given us a presence on-prem that really feels like what we're doing in the cloud. We get a lot of the same agility, a lot of the same flexibility that we get in the cloud. So it's been an incredible journey, and it took us a little while to kind of get to this design on-prem. But like Lance said, with that kind of upstream architecture that we had for just getting traffic into the 8x8 larger network, it made it really easy to plug in another Kubernetes cluster into our data centers. And I have one more really quick set of points here, and Pankaj really kind of hit a lot of these in his kind of intro. But a lot of these were key decision factors for 8x8. We needed BGP support. We needed support for that horizontally scalable, zone-aware infrastructure that we wanted at our quote load balancing tier. We wanted that seamless integration with Kubernetes. We didn't want to mess around with some vendor specific or some off the wall APIs or integration that required a lot of changes on our application side, and Citrix was made it really easy to plug in our applications.
Yeah.
And you know, one of the things that I don't think we talk about enough is the licensing was really flexible. We do have some existing Citrix deployments, some NetScalers within our kind of more I don't want to call it legacy, our legacy infrastructure. And what's nice is that you know, we have some experience with Citrix, and Citrix has been a great partner for years for 8x8. So it made that move into kind of operating ADC tier in Kubernetes. It made it that much simpler.
Nice.
So, anyways, yeah, that's what we're doing in the data center. It's been a like I said, a fun ride, and Citrix really made it easy to kind of give us that cloud-like experience in the data center. Anyways, I'll give it back to you, Lance.
Yeah, I mean, when they first offered up the new clusters on-prem, I think, you know, it took us all of 5 minutes to learn what the new annotations were, and then like 30 services were deployed without changing anything in the Helm chart, and it was fantastic. So
yeah, that was a pretty exciting moment to see all those servers pop up with almost no work.
Yeah, it really validated the whole choice of Kubernetes at that point. So a few recommendations that I would give. Basically, you know, if I had the chance to go back in time and talk to us 2 years ago, you know, these are some of the things that I would say, please, dear God, pay attention to these things, you know. So one, you know, choose your battles. As we were learning Kubernetes is really hard. It's got a steep learning curve initially, and so we just said, you know, well, we'll just start with stateless applications first. We had it was a new paradigm for us, so there was a new framework that helped us a lot. That helped a lot. Along those lines, we got very strong alignment and partnered very, you know, with the group in engineering that was defining how microservices were going to be implemented at 8x8. And so if those guys aren't your best friends, then, you know, you got to work on that. Wanted everything to be self-service. Once you lift all the developers up into the state definition that is Kubernetes, then they can go along and getting their stuff done and making changes and updating things, and then you can work on the cluster and you know, make sure that it's healthy and stays running and everything and stuff like that. So it was critical to do that. You know, we went cloud first, mainly just so that we wanted to make sure we didn't have anything that, you know, had a kind of a pre-existing identity to it. You know, we're 25 years old company, you know, data centers and physical environments, just as the nature of the organic growth of it over time, it will have an identity to it. So we didn't want any idiosyncrasies within how, you know, traditionally we've done things to affect how we learn something. And plus the cloud environments are 100% automatable, like everything from day one. So that was huge. And this next one actually got us, and Mike and I can laugh about this one, you know, because we felt the pain on it. But out of the gate, without putting any effort into it, or just kind of the initial install of Kubernetes, it doesn't do anything to protect this cluster from runaway consumption of resources. So there's a way to start up the nodes and tell the kubelets and whatnot, you know, you can only have this much of the operating system, or at least reserve a certain amount of the operating system resources for the operating system. And then per namespace, there's a limit resource definition that, you know, if a deployment doesn't have deep limits set, you can give it some sane settings. Otherwise, one pod can easily crush a whole cluster, and Kubernetes will happily just crush a node, move to the next node, crush a node, move to the next node. And so that was a fun lesson to learn. But
one thing I want to throw out there related to that is, you know, there's a lot of great tools out there, you know, on the internet, GitHub, including even in Kubernetes, the source tree for Kubernetes, they have the resource consumer pod. So there's a lot of ways to actually test that these limits are working or not working. There's a lot of cool tools out there. If you can't load test, directly with your application, there's a lot of things you can deploy into Kubernetes to simulate load, test your auto scaling, test your limits, all of that stuff. So I just wanted to throw that out there.
Mm-hmm.
Yeah. Citrix has also published a lot of examples and code on GitHub. So if you want to download sample proxies or get the configuration insights, you can always do that through GitHub. One quick question for you, Lance, is out of these 5 recommendations, which was the most difficult one and which one was the easiest one?
Mm-hmm. Well, it was easy to choose to just only do stateless. We were fortunate enough that the alignment really worked out, but I imagine that can be the hard. I mean, cultural changes is really the hardest thing you can do at a company, right? So, but we were really fortunate that the team that we worked with was great. So we lucked out there. But I would say the choose your battles is the easiest because you have control over it, and then alignment would be the hardest.
Thank you.
Mm-hmm. So moving on, some of the other recommendations. We punted on service mesh initially just because everyone's first reaction was, well, Kubernetes is hard enough. Now you're going to add yet another layer of abstraction, which I know solves everything, but it still adds a lot of complexity to it. But in retrospect now, it's much harder to kind of introduce that once you're already got a pretty robust set of services in place. And if a developer doesn't have the tool available to them very readily or easily, well, the first thing they'll do is write it. So like without that, embracing that, then, they have to do something to kind of get the same kind of features, and you'll end up maybe structuring yourself into something that's harder to introduce later. But it comes with a lot of good stuff. You get telemetry, you get much better security, and it's much easier to actually connect disparate clusters once you start having many clusters. For security, I would limit the kubectl access. It's essentially God mode and everybody wants it, but it is the most dangerous way of manipulating or working with a cluster. Helm is much safer. It's like Yum repository and Yum commands for your microservices. It's great. We ended up creating a cluster role for a power user that allowed us to kind of reintroduce kubectl, but we kind of pulled their feature set away from what Helm would take care of and the deployment objects would take care of anyways, and that was kind of the best of both worlds. Along with kind of the same lines as the service mesh, ingress is more complicated for people to understand with respect to the Kubernetes setup, but I would go with it over services, just because it works better in the cloud, and with respect to it doesn't spin up a brand new load balancer for every single service you have. So there's a cost optimization to it. And then there's a lot of really cool stuff you can do at the ingress layer dynamically as people hit URLs and stuff. And you can get more telemetry out of it. And then the last two are actually regardless of Kubernetes, but it's just that much more paramount when you have an ephemeral environment where your containers can disappear at a moment's notice. You got to get your logs and all your metrics off and aggregate it somewhere that the teams can look at it. And so we use daemon sets for collecting the metrics and the logs, and we send it off to log aggregation. Prometheus is fantastic. We did start with that. We eventually ended up using New Relic because the engineering teams brought in an APM, and so it also has OS level stuff and monitoring of Kubernetes clusters. So it actually really looked great together because the application team could go from an application event directly into whatever physical hardware was going on and the monitoring of it. So it was a good marriage of those two. And those are it. So I'll hand it back to.
Thank you, Lance. Thank you, Mike, for great insights. We learned a lot. Jeremy, back to you. If you have any questions.
Yes, we do. Thank you, Pankaj. We do have a few questions. So as we move into the Q&A, I'll remind our audience that if you do have a question, please submit it in the Ask a Question area on your screen. We have a few minutes for them. So these look like they're really for you guys. So I'll let either of you take it, Michael or Lance. The first one is, are you using the Citrix Application Delivery Management Tool, ADM, to manage your ADC implementation?
Yeah, I can speak to that. We are using ADM, like I mentioned earlier, 8x8. We do have a long relationship with Citrix, and so a lot of our existing NetScaler ADC infrastructure that's sitting in front of some of our monolithic applications are using NetScalers managed through ADM, and that's kind of a new thing for us as well. So we're learning that, and we're getting more familiar with that. But I know that a lot of our teams that are working more with the monolithic apps are really embracing ADM. And our plan is to bring in the VPXs that we're putting in front of Kubernetes into ADM management as well.
Excellent, excellent. Here's another ADM related one. What tools are you using for visibility in your microservice environment right now? And will it work with the ADM solution?
Yeah, I can start with a little bit with that. I mean, we used, like I said, we used Prometheus and the node exporter to kind of get the data off the nodes, and then Grafana to kind of see it in Prometheus. But we also sent it to via New Relic, so there's multiple avenues to the same metrics, and then with the ADM stuff.
Yeah, and I think that to kind of continue on that, we do have a lot of within our infrastructure, a lot of different tools that we're using. It's probably like any company that's been around for 25 years has like every single monitoring and observability tool you can imagine running. And ADM, unfortunately, becomes another one of those. But it does have some unique, it's in a unique position to kind of give us a lot of that east-west, north-south visibility, especially as we start doing more of the service mesh and those sorts of deployments. It's going to be really useful for stuff like that.
Yeah, that's great.
It also helps if you are deploying service mesh, so you can use the service graphs, which shows you how microservices are connected to each other, what is the health of each and every microservice. It can give you the alarms before problems appear for you. So it's a very comprehensive tool which gives you much deeper insight for not just for north-south as well as for the east-west traffic. And you can deploy your ADCs in any environment, and you can still manage them across the multi-cloud.
Exactly.
Yeah, I know that's one of our biggest competitive differentiators, and so I love to hear those kind of stories. And then we have time for one more here. What cloud solution are you using? Between AWS and on-premise, was there an advantage to using AWS?
Well, we started. It was probably the most feature-rich at the time when we started using the public cloud. But at this point, the Kubernetes story in itself, it's my elevator pitch for it is it takes the best of any of the best clouds and lets you put it anywhere at that point. Like you get the exact same kind of functionality and features that really make it shine. And then it allows you to truly be a hybrid multi-cloud. Because like I said, once we lifted the developers up into the Kubernetes manifests, they literally don't even know if it's an EC2 instance or a VM somewhere or GCP or whatnot. So we use Amazon. We started with Amazon where we had a little bit of a GCP, and now we're going with OCI, the Oracle platform.
Wonderful. All right. Well, I think that brings us to the end of the presentation. Thank you so much, Pankaj, Lance, and Michael. This has been a really amazing discussion. I know you guys, had some really terrific insights to share with our audience, and I'm sure they're finding that really valuable. A quick reminder, we have lots of other events coming up. If you want to check that out, you can visit citrix.com/events. And you can also visit any of our great speakers on the social handles that have been shown here. Make sure to follow them. They have a lot of great information like this to share all the time. So thanks, everyone. Thanks, guys, again, and have a great afternoon.
Thank you.
You too. Thank you.